So today we're going to be dealing with 10.3, which is modeling with exponential growth and decay functions. And just like before, when it's a worksheet, we're going to tape it into our notebook. So I'm going to tape mine into my notebook. You guys can be doing the exact same thing to yours. Just going to go down and tape everything. And then we're going to go ahead and start right on in what we're doing today. So modeling with exponential growth and decay functions. So the front of this worksheet is 10.3, which is today's notes. Tomorrow we'll be doing 10.4, which is the back of this worksheet. So today is just about the front of this worksheet. It's not about the back at all. So it's asking us to graph the function on a graphing calculator and state its domain, range, and end behavior and an asymptote. Okay? So we're going to take our graphing calculator, and for those of you that don't have a graphing calculator in front of you, you can use Desmos. So I'm going to go into y equals. I'm going to delete both equations that I had there from before, and I'm going to put 200 parentheses 1.92 to the x power. Now, before I graph that, let's go over things that reminders from before. So from before, we know our a value is 200, our b value is 1.92. Does that mean it's exponential growth or decay? Based on our b value, it's going to be growth. So when we graph this, it should be growing exponentially. So I'm going to go ahead and, before I do that, actually, I just thought of something. I'm going to reset my memory. So I'm going to go second plus 7, 1, 2. And my RAM's cleared. Now I'm going to go back in and put that in. So 200 parentheses 1.92 to the x power. Now, we know our y-intercept is 0, 200, right? And we know it's not going below the axis. So I could go to my window and I can say my smallest y value is 0. We know we're going to go past 200, which means we're going to have to go, our y max is going to be way more than 10. So I'm just going to do 500. And then I'm going to hit graph. And let's see if we can see that now. So there's our exponential growth graph. So if we look at our domain, it's going from negative infinity to infinity. Our range is starting at 0, but it doesn't hit 0 because that's our asymptote, to infinity. And then if we do our end behavior, as x approaches infinity, what's happening to our y value? Y is approaching infinity. And then as x approaches negative infinity, what's happening to our y value? As x is getting bigger this way, our y is approaching 0. And our asymptote is still y equals 0. Then we go to this next equation. We have our a, we have our b. Is that growth or decay? Because it's between 0 and 1, that makes it decay. So now we also know our asymptote is still the same, y equals 0. So we go to y equals, we're going to clear what we have there. I'm going to plug in 43 parentheses, 0.68, close the parentheses, to the x power. Now remember, if you're using Desmos, you just plug this into Desmos. You can do that as well. Now, what's our largest y here? I'm sorry, not what's our largest y. What's our y-intercept? It's going to be 0.43. So we have to go beyond that. So let's see if it's going to show on our graph. There we go. So what's our domain? Domain is still negative infinity to infinity. And then our range, still starting at 0, going on up. So it's still 0 to infinity. The difference is going to be our end behavior. So on this one, as x is getting bigger and bigger and bigger, chasing infinity, what's happening to our y? It's getting closer to 0. As x approaches negative infinity, So x is getting bigger this way. What's happening to our y? It's actually getting bigger, so it's getting closer to infinity. So what does a represent in an exponential function? It's kind of a reminder from yesterday. What does a represent? It represents the initial amount. And what does the b represent? It represents the rate of growth or decay. What does x represent? Well, it depends. It could represent time. A lot of times it represents time, but in this case, we're going to say it's our independent variable. It doesn't rely on anything. And then f of x relies on our x value, so that's going to be our dependent variable. That's kind of talking about what they stand for. So knowing this, you can write an exponential equation to represent the following situation. So if we go down here to this first one right here, 5 students started a rumor. So what does that represent? Is that our initial amount or is that our growth or decay? It's our initial amount, so that's our a value. Every hour, the number of students that heard the rumor doubled. What does that mean? That's our b value. So how would we write this? F of x equals a, which is 5, b, which is 2, and then x represents hours. And that's all it is to setting it up. So let's go to the next problem. Sally walked into a casino with $500 in her pocket. There's our A. Every hour she gambled away 1/4 of the money. There's our B. So if we write it, f of x equals 500, 1/4 to the x. What does our x represent? We're talking about hours, so same thing, hours. Remember, usually it represents time. So now we go down to the bottom part. Decide whether the following keywords represent growth or decay. So depreciate, does that mean you're gaining or you're losing? So depreciate means you're losing, so that's going to be decay. Increase, are you gaining or losing? You're gaining, so that's going to be growth. Something doubles, are you gaining or are you losing it? You are gaining it, so it's double, goes under growth. Loss, of course, that's decay. Something tripled in value, that means it became more, so that would be growth. Appreciate is the opposite of depreciate. It means you're gaining, so it's going to go under growth. Decrease, you're losing, so that goes under decay. And if something's cut in half, that means it's decay as well. Now, exponential growth model, we were talking about it yesterday. I'm going to remind you of yesterday. So if you're going up 5%, you're really going up 1.05% because you're actually adding it. So when we're writing this, we're going to growth is f of x equals a, just like usual. This time, since we're talking about rate, we're going to do 1 plus r to the x. And a lot of times that x that we're talking about right there and that x right there, we can replace them with a t because usually we're talking about time. Decay, f of t equals a, it's going down, so it's 1 minus r to the t. So same thing as before. A is our initial, or our initial amount. R is our rate, which is usually a percent, T is time, and it could be hours or it could be seconds. It's just depending on what you're dealing with. So growth is this equation, decay is this. The only difference is one is a plus, one is a minus. So let's actually go into use these right now to do some problems, some word problems. So identify if the situation is exponential growth or decay. So we need to figure out whether it's growth or decay first. Then write an exponential function for the situation. So an antique ring is valued at $10,000. There's our A. And is appreciating. Is that growth or decay? That is growth. At a rate of 5%. There's our R. So is this growth or decay? We just said it's growth. Now we're going to write our equation. So f of t equals A, which is $10,000, 1 plus 5% to the t. And there's our equation. That's all it is to writing your equation. Now, one of the things that they always want you to do is they want you to simplify. So can we simplify this? Yes, because these are like terms. So my final equation is f of t equals 10,000, parentheses, 1.05 to the t. And that would be my equation for finding out the value of that ring after each year. So if we go to the next one, a computer is valued at $1,200, there's our A, decreasing, which means decay, at a rate 17% each year. So there's our R. So if we write this, we have f of t equals 1,200, 1 minus, since it's decay, 0.17 to the t. Just like on the last one, we're going to combine our like terms there, and I get f of t equals 1,200 times 0.83 t. And that is our equation. Now, these next ones are actually not only asking us to write an equation, but they're actually asking us to solve it. So if you notice the directions, say write and solve. So for number 7A, a painting is sold for $1,800. That is your A. And its value increases, which means it's a growth, by 11% each year. There's our R. So if we write our equation, f of t equals A, which is 1,800, parentheses, growth, 1 plus 0.11 to the t. Is it completely simplified? No, it's not. So f of t equals 1,800 times 1.11 to the t. There's our equation. Now, the next question is asking us to find the value of the painting in 30 years. Wants to know how much is it worth in 30 years. So there's our t value. So f of 30 equals 1,800, 1.11 to the 30th. And then all you do once you get to that is you're going to plug it in your calculator. So 1,800, parentheses, 1.11 to the 30. Remember, our answer's got to be in money. So in 30 years, that painting is going to be worth $41,206.13. That is a lot. So in 30 years, it'll be worth that amount of money. So you would say, in 30 years, it's worth approximately $41,206.13. So now we go to the next one. The value of a car is depreciating, which means decay, at a rate of 5%. There's our R. In 2010, the car was worth $32,000. There's our A. So we start off by writing our equation. So f of t equals 32,000. Decay, so 1 minus 0.05 to the t. Combine my like terms, and I get f of t equals 32,000, 0.95 to the t. There's my equation. Now, find the amount in 2013. So we started out in 2010, 2013. How many years later is that? 3, so t is 3. So I plug in a 3, and I get 32,000 times 0.95 to the 3. Remember, this is money. So same thing, we're always going to put our answer in terms of money. 32,000, parentheses, 0.95 to the third. And you get 27,436, and it's exactly that amount. This is money. So in your answer, you would say, in 2013, the car was worth $27,436.00. Going to answer the question very thoroughly. Now, you're going to hold on to this worksheet because tomorrow we're going to be doing the back of the worksheet, and your homework tonight is an HRW. Now, you've seen the kind of work that I showed here. That's the kind of work you're going to have to show on your homework. Okay? Have a great evening.